So good afternoon, everyone. Today's class is about the propositional logic. You have done the debate successfully, so thank you very much for the participation. Right. So we'll come back to the real logic curriculum. So you can go to Google Classroom and then open the slide about propositional logic. Propositional logic. There it is. Last time we were in here. So yeah, this slide. Okay. So I hope you still remember. Propositional logic mean you have proposition, the logic of proposition. So the meaning is proposition. This is the what is proposition? Anyone still remember? What is proposition? Still remember what is proposition? No? Not remember
A statement.
Statement. Is it just a statement or special?
It has to be positive. It has to be wrong or right.
Okay.
Yeah.
True or false. Right. So it's a specific statement that has truth value. Okay. So when we do a propositional logic, so it's better to have some kind of form. So the form is we put it into kind of formula, something like this, right? So then you may ask question why we want to put it into formula like this. Right? So using this formula, we can manipulate easily. Okay. That's why. So in the old eras, so for example, from the 200 years before Christ, yeah, until maybe early 19th centuries, okay, what we said as logic is always just sentence, just statement in English, okay, or in their own language. So, but when we start to create the form in terms of formula like this, then actually we can solve the logic easier, okay, using computer, using a programming language that you want. And nowadays, because of this, okay, we can also create automation. Okay. Now, I want you to, in this simple, now this is our last lesson, right? So today is either Monday or Tuesday. Today is not Monday. Thus, today is Tuesday. So this is the first premise, second premise, and the conclusion. So from here, we can put into this form either P or Q. What is P in this case?
Monday.
No, P in this case means today is Monday. Right? How about Q?
Today is Tuesday.
Yeah, today is Tuesday. Okay. Then it is not the case that P, that means today is not Monday. Then today is Tuesday is Q. Right? So then you can also put it into the formula. Okay? So P or is like this, Q, right? So this is the first premise. Okay? And then you can put either comma or you can put and. Right? What is this? And not P. So we put it not P, then Q. Right. So when you put it into formula, you will put it this way. Okay, so this is the example. Now how about this? Anyone can do the same. If you look at this, the form is exactly the same. Okay. If P, then Q, and then what is this? P plus Q, right? So if P, so we will put it into, this is still example, so I will put P, then Q, right? And then the second argument is P, so I will put N, okay, so I will put N like this, and P. So thus Q, so you can put thus Q. Okay, can you make it into formula like that? Okay, so who can do this into formula? You can write here if you want. Come on. You can annotate. Or you can type in your notepad and then you share your screen. It's also okay. I will allow you to, oh, okay, can I just write that? P, either P or Q, correct, and then N, yes, is not what? It's not P, okay, therefore, okay, Q. Excellent, excellent, okay. Is it clear? Like something like this? You can make it, right? Everyone? Is there any question about this? No. Super easy. Again, practice. Who want to write? Jocelyn, okay, try to write here. If you have good grade, you are eligible for scholarship. So P and Q. Okay. Then you have good grade. Okay, and P. Therefore, okay. So we have been using the same form, isn't it? Yeah. This one and earlier, you see exactly the same form, right? So very good, Jocelyn. Yeah. How about this one? Is this the same form or not?
The same.
The same, yeah. So if P, then Q, then N, what? P. Okay. Therefore, Q. Okay. So this kind of form, okay, you remember? What is this? There is a name for this form, right? Okay. The name of this form is called modus ponens. Okay. If P, then Q. P, then Q. Okay, so this is called modus ponens. Okay. So there is another form of logic which is called modus tollens. Okay. If P, then Q. Not Q, then not P. Okay. This is the form of modus tollens. Okay. I hope you remember modus ponens and modus tollens. At least. Yeah. How about this one? Who can do? Alicia, you did not do. Okay, come on.
me, sir?
So you can write here, or okay. P or Q, okay. And then for the next argument, you use comma or you use n. That's the same thing. Not what? Not P. Okay. Therefore, okay, it's the juvenile is Q. Yeah. Very good. Yeah. Okay. How about this one? Is this the same or not? Oh, I think this is the same, right? Oh, no, this is not the same. Is it? Is this the same or not the same? What do you think? How to clean the annotation. So, how about this one? How are you going to write the form? Anyone to try? Billy. P or what? Not P or not Q, okay. And then comma not P, okay. Therefore, not Q. Hmm? You see it?
I think it is.
No. What's the difference? No, this is not correct. Yes, with the no, right? So because now, if you have this, this is actually the same as earlier, okay? A previous practice. You just put the R equal to not Q, then exactly the same as previous argument. Okay? So you can put,
So I want to ask,
yeah, please.
if we can go at all SQ, is it okay or not okay?
If you
If
want,
we can go at all SQ, is it okay or not okay?
yeah. So this is exactly what I want to say. So instead of Q, I will put as R. Is that okay? So I will put P or R, not P, Therefore, R. Right? It's the same thing because you can say that this is actually, even if this is negative, right? You can put it as one sentence, one proposition is called R. What Billy was doubt a while ago is because, oh, this one is supposed to be, when you put in here is can go at all as not Q, right? Then this one must be not Q, right? The same. So if you don't want it, you can put it as positive. So then I'll call this R. So, possible? So you can replace, the negative part you can replace as positive, no problem. Okay. Okay, so then, how about this? Is this the same? No, it's not the same. So Matthew, clean up this and what is the argument form of this one? If Murphy's law, do you know Murphy's law? Have you ever heard? Oh, check. Go to Google. Google it, okay? If Murphy's law is valid, then everything goes wrong. Can go wrong. But not everything can go wrong. That's Murphy's law is not valid. So, Matthew, can you put this into an argument form? I will clean the drawing. Now you go.
And sir, is it the argument correct, sir?
Where do you put it?
Oh, not yet, sir. I'm just confused.
Oh, okay. Which one is the part that make it confused?
I don't know because it's like if then right, but then the second is but not everything can go wrong, then Murphy law is not valid.
So you put a variable. Okay, let's name it P. P equal Murphy's law is valid. Okay, and then Q. What is Q in this case? Q will say anything can go wrong. Okay. Then Q is what? Anything can go wrong. Okay, so with that definition, okay, now you can start to write the form. Okay. What is the first premise? If P, then Q. Okay, very good. The second premise is not everything can go wrong. That means not, no, Matthew. Okay, everything is the same. Okay, in propositional logic, we don't care about the actual sentence. Okay, the meaning. Anything can go wrong is already Q, right? So in here, but not. Okay, everything can go wrong. So that's not Q, correct? So then not P. Okay, very good. Yeah.
Okay, thank you, sir.
Okay, very good. Okay, clear, yeah? With this kind of practice. How about this one? state clear all true. Okay. Who want to do this? Who did not? Everyone is already there. So, okay. So this is the optional. Come on. Who want to do this in here? You.
Yes, sir.
Oh, you can try. You can try. If you pass the test and Jane also passed the test, so did Olaf. Olaf did not pass the test. Thus, it is false that both of you and Jane passed the test. Or can you make it into argument form? So, first you define, okay? P is what? P is you pass the test. Okay? So P so P in here is you pass the test. Okay? How about Q? Jane pass test. Okay? And then R, what? R mean Olaf pass test. Right? So, with that, can you make the argument form? Want to try? Okay. If P, what?
Neville.
Nephew, okay. P and M is like this, yeah? N. N is like V, but reverse. Yes. Q. Right? Q. Okay. So did Olaf. What's that mean?
Wait, sir, I'm so confused.
The first premise. Can you do it? The first premise. This is almost correct. This is the condition. But this is if then. Then you will do what? Arrow. Yeah. Arrow to R. Correct. And then the second premise. So you put N. Right? So put all of this into bracket. And then you put N. No. Okay, you put all of these into bracket. Yeah, very good. And then now you put N. Because first premise and second premise must be N, right? Okay, what is the second premise? What is the second premise? Olaf did not pass the test. So, how do you put that into? Olaf, what is Olaf? Q is Jane, right?
Okay, sir, I'm sorry. So this one is R,
Not R,
not R. Okay.
right?
Um,
Not Olaf did not pass the test. And then, so you therefore you put arrow again. So you can put all together into another Oh, what is this? If it is false that both of you and Jane passed the test. Oh, what is that?
P and key.
P and Q, and then it is false that. So what is that?
So
It
P
is
and Q.
false. Oh, it is false. That means the not of P and Q.
Oh, okay. Not P and key.
Yes, but should be not of P and Q, right? Okay. So how's it? Is it difficult or easy or just need more attention? What do you think? So what is the step? Number one is to define the variable. Okay. Number two, from the variable you put the form. So you check, yeah, the keyword if, then, and, or, not. Okay. So only a few keywords. So there is one more, if and only if. So up to here, is there any question?
Sir, I still don't get it, sir.
You still don't get it. Okay. Which part you don't get?
This is like the statement, right?
Mhm.
Wait, let me see the PPT.
Okay, let's you try on your own then. Practice. This practice page. Which one is the practice a while ago? The Olaf. Okay, can you practice the Olaf?
The Olaf, I can make it into the form, sir, but I still don't get it. It's like an if-then statement, right, sir? But why it's Olaf did not pass, then both you and Jane passed the test. It's
No, no.
false that you and Jane.
Uh, I'm not asking about the truth value here yet. Not yet. I'm just asking about, can you identify the argument form? Okay, whether this is true, valid argument or not, it doesn't really matter at this point. Okay, the practice here is just to put from sentence into what? Into the uh, formula. Into formula.
Oh, okay, sir. Thank you, sir.
Okay, there's no problem. After this, we will check the formula. Okay, so step by step, right? The first step is to put from the sentence, the English sentence, into formula. Okay, the step is to put the variable. You need to define the variable. Okay, and then you put the formula. So my question to you, can you make the form? The argument
Yes, sir,
form?
but
Yes, no problem.
need to be more attention.
Okay, then let's practice again. Huh? Okay. Now, this is the next step. This is the next step. Okay. Once you can put into argument form, okay, the next step is to check. Oh, what happened to this? Okay. The next step is to check the truth value. Okay. If you want to check the truth value, okay, then you put it into Excel or you can do it manually. Oh, okay. Can you check why this argument is invalid? Can you make a truth table? How do you make a truth table for this? So I will give you a clue. Huh? Number one, you will create what? P, right? Number two, you will create Q, right? And then after that, you will put P Q. Another column is what? P and Q and Q. Okay. And then what is the last column? The last column will be P and Q and Q, P. Okay, so if the last column is a tautology, you know tautology, right? All are true for all the values, all the possible values, then this is valid. If this is not tautology, then it is invalid. Okay, so what is the value of P? Okay, true, true, false, false, right? What is the value of Q? True, false, right? So you compute, okay? Okay, after that you share to me. You create an Excel. And then everyone will share their work, okay? So the earlier practice is to translate from English into argument form. Okay? Now the practice is to check the validity of argument form. At the end of this semester, you will master this because we'll practice a lot, okay? Until you feel very bored.
And sir, what we have to do in Excel?
Oh,
I
you don't
miss it,
need.
sir.
You can use Word, or you can use Notepad, or you can use what is that called? Paint. You don't need to use Excel, but Excel is easier, yeah? Or you can use paper and pen.
Oh, what is the question, sir? My internet is very
Oh,
bad.
the question is, can you check the validity of this argument form? Okay, using truth table, check why this argument form is invalid. I'm telling you that this is invalid. But why? Right? Can you make it? This is the real logic. Anyone want to share your screen?
So is it because it's not tautology?
It's not because it is not tautology. So can you prove it that this is not tautology?
I don't know.
Yeah, that's correct. This is not tautology. So you have P and Q, right? And then P and Q, if P and Q, okay, and then, okay, no, the last one is P. No, that's correct, but the last one is, that is Q, right? And then not does P.
Wait, I think I'm wrong. Wait. Where is the question? In where PPT
The question is
in which PPT?
in the 17 propositional logic, page 20. Can you find it? Propositional logic, page 20. And so if P, then Q. Q plus P. This is one of the fallacy. Remember we discussed about fallacy. So people often use this form, which is actually invalid. Okay. If then does not mean then if. It's one way, not the other way around. Okay. This is the source of confusion of people who does not know logic. Okay. So this is invalid. Go. So you can check, okay, whether an argument is valid or not, right? This is what we learned today, right? So first, if you have an English sentence, you need to put it into form, okay, into variables, okay, in the formula. Once you make it into formula, it's easier to handle, right? Because it's just one letter, okay, for one sentence. Then you can put it into Excel, for example, or you can do it on your own manually, okay, to check whether that is tautology or not. Okay, if it is tautology, okay, then the argument is valid. If it is not tautology, then the argument is invalid. You remember tautology is all true.
Oh, I got tautology.
You got tautology?
No, no, no. Not tautology, sir.
Not tautology, yes. So which one is the actually make it wrong?
Oh, I will present my
Okay, you
Excel.
can present. Okay.
This one, sir. This is
Okay.
false.
Yes, that is false, right? So this is the source of confusion in many argument, right? Because they thought because the three of them are true, mean everything is true. It's not. Okay, if the P is false and Q is true, then it is false. So it is not tautology. Therefore, this is invalid. Okay, sometimes look like valid, okay, but not all the time. So in that case, invalid. Very strict. Very good, Felicia. Okay. So can everyone make it? Is there any difficulty? No. Matthew, can you make it? Yes, you feel?
Yeah. Mm.
Billy, no problem.
Yes, sir. No problem.
Mm-hmm. Joyce, Jocelyn,
No, sir.
no problem, right? Okay. Okay, let's continue then. Okay. So if the result is not tautology, don't forget it is invalid. Okay, because some form are valid but the others are not. Oh, let's check this one. In page 22, can you check using truth table whether this form is valid or not? Okay. Next meeting, early next meeting, you will have a test. Okay. It's a simple test, just 5-minute test, 2 questions. Okay. Just like this, exactly like this. Okay. I will not ask you to do a truth table, so I will just check. The question will be whether this following argument form is valid or not. Okay. Or which of the following argument form are valid. So you need to check, okay, all the possible correct answer. Okay, now how to check you need to do using, okay, one way is to do using truth table. Okay, next time we can use algebra. Okay, so can you do the truth table of this? Can you do the truth table of this one? Either P or Q. It is not the case that P does Q. Can someone show the truth table? Either P or Q. Okay. It is not the case that P plus Q. Of course, you need to create the argument form first, right? And then you can check whether it is tautology or not.
I get tautology, sir.
You get tautology, excellent. So can you share your screen so that everyone will see?
Oh, yes, sir. Yes.
Oh, okay, so you get the P or Q, not P, right? And then you put N for that, and then you put if then, right? Excellent. So you get tautology. So this argument is valid. Okay. So is there any question about this? So now I want you to do the practices. Okay. In that slide, have four more practices. So can we assign one of you? So in page 25, 26, 27. So this is the one. Right? So a while ago, this is 24. Okay. Either P or it is not the case that Q. It is not the case that P. Thus, it is not the case that Q. So can we assign this to who? Who will do? Jocelyn, can you make it? Jocelyn.
Okay.
Okay. Okay. How about this one? Billy, can you make this one? This is, what is this? This is modus ponens. Billy, can you check the validity of modus ponens?
Yeah, I will check this one.
Okay. How about this one? This is modus tollens. Okay, so Newfield, can you make the truth table of this modus tollens?
Okay, okay, sir.
Okay, and this one. This is, if P and Q then R, it is not the case that R. It is not the case that P and Q. Who will do this? Kenneth, can you make this? Okay, Kenneth?
Yes.
Okay, good. So now, Matthew, I want you to be more complicated than that, okay? So here it is, the one that you said a while ago, it is not valid or valid. So page 19, Matthew, this is your job, okay?
Okay, sir.
Okay, it's not there. So if you pass the test and Jane also passed the test, so did Olaf. Olaf did not pass. That it is false that both on you and Jane passed the test. So you put it into argument form and then you create the truth table. Okay, who did not do yet? Cannot finish, Matthew finish, Newfield finish. Oh, Felicia not yet. Okay, Felicia, one more. Felicia, Murphy's law.
Okay,
Okay.
sir. I'll
Oh,
try it.
you try this. Okay. From here, you create the argument form, and then you create the truth table. So We don't know this is valid or not, so you check. Okay, I don't know, so okay. At least now you get directly now from the sentence, the English sentence, into the truth table. Okay, now you can check the validity of an English sentence. Then you show me. Huh? There is no answer in the slide, so so if Tamara is not coming, she need to do all of this. Okay? The one that you did only one, she need to do all. Right? So next meeting, test. Okay, I will take a note. Okay, I will create a test. So you come early in the beginning of the logic class. Next meeting, I will create a quiz. So propositional logic 1. So we will have a lot of tests for the propositional logic. That will be next week 16. Quiz. Schedule on 16. Our class is 14:30, so then I'll put it as 14. 5 minutes enough to solve this, or 10 minutes? 10 minutes.
10, 10.
10, okay. Only 2 problems. 10 minutes, okay. So I will schedule for next week, 16. That is 14, 25. Okay. Schedule.
Sir, can I share screen? I don't know why am
Sure.
I wrong.
What was your problem again a while ago? You're supposed to do which one?
The bottom, the most bottom one. Page 25, slide
25.
25.
Okay. Oh, so
Slide
modus ponens.
Ponent. Yep.
Modus ponens. P and Q. And then if P, then Q.
I don't know why is it wrong.
Why is it wrong?
Yep.
Maybe comma instead of ano?
Semicolon.
Instead of semicolon. Oh, semicolon. Okay.
Yep.
Oh, I think I know is why is it wrong? Because P and Q must be true or false, not T.
Oh, I should write it through.
Yeah,
Is it?
true. True. Enter. Enter. There.
Oh. 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 Okay, sir. Thank you.
For the page 27, is it
Hmm.
not tautology?
27.
It's not valid.
I don't know. Can you show it? If P and Q, then R. It is not the case that R. It is not the case that P and Q. So this is modus tollens. Modus tollens, this one must be valid, you.
Must be valid.
Must be valid because this is modus tollens. Right, so let's check. Okay, P
Oh, wait.
P and Q and Q. Where you have or there? And there, not or.
Oh,
Oh, that 27, right?
yes,
Should
yes,
be.
yes.
Yes, that must be and, not or. P P and Q. Is that correct? If you memorize a few of them, modus ponens, modus tollens, disjunction, conjunction, those are the a few logical form that we often use. So that will make your life easier. This is clearly modus tollens, so it's valid. So what is the okay? Can you check the F column F? Can you show the formula? N of D and E. Why you put there P and Q, but your formula is Q and R. Should be C and D, right? That one is if. What is this? If F. No. F. You already have that. P and Q is already there in column F. In column F.
Wait,
No.
wait. I think I.
Your column G formula is incorrect. If column F is true, then yes, correct. That one is correct. Enter and then you copy down. what is this? This is the premise, the two premises together, right? So that means the G and H. Okay, correct. And then this one is the I will produce not. It is not the case that P and Q is not of P and Q. That formula above is incorrect. Not of the two. Yeah, like that. So
Wait,
not. Okay. So this is the real mathematics of logic, right? While you can do manually without the help of any program, including Excel, you can do, okay, but it takes longer time. Is it working? Kenneth, did you get tautology?
yes.
Yes. Oh, Kenneth, I'm asking you now. Why do I tell this is modus stolen? Why this is modus stolen?
Because it is not the case that
So,
so the first premise is if then, and then the second premise not the case that, and thus it is not the case that the
so
other.
if you replace P and Q into something else, for example, S. If S, then R. Okay? It is not the case that R. Thus, it is not the case that S.
Yes.
Then become modus stolen. Exactly. Right? So the S in here represent P and Q. Okay? So very good. Okay, you got it. So who else want to share your screen?
Me, sir, I will present my screen.
Okay, Felicia, which slide number did you a while ago? Murphy's law, right?
Yes, slide 18.
Okay, slide 18. Okay, show your screen. Where is it? P. Okay, okay. So P. If P, then Q, then is not Q. Is not Q. And then is not P. Oh, so the argument is valid.
Yes, valid, sir.
Yes, this is valid. Okay. Oh, in fact, this is modus stolen, so it must be valid. Okay, excellent. So, who else? Okay, final.
Me, sir.
Okay, Matthew. Matthew is Olaf. P. Oh, what happened? Olaf things. I cannot see.
Yeah, is it already, sir? Visible?
Why there is some block that I cannot see?
Oh, wait. Mm, okay. Is it possible, sir?
How about all of you? Can you see it or not? I did not see it yet. Maybe some takes some time. Billy, can you see Matthew's screen?
I cannot see too.
I cannot see also. Okay. I cannot see Matthew, sorry.
I think my Zoom is quite trouble, sir.
Yeah. So is it valid or not? That's the question.
Oh,
Valid?
no. I got
No?
not topology.
Oh, yeah?
Yes, I got not tautology.
19. Not tautology. 19 is supposed to be the same as wait. If P, oh, no. If P and Q, then R, right? And then
Mm.
not, and then not R. Then it is not P and Q. So it must be valid, you. Why is it valid?
Oh, wait, sir. I forgot the not.
Hmm. This must be valid, you, because this is modus tollens. Okay. Try to memorize two forms, modus ponens and modus tollens. The one in the slide earlier. Okay. Modus ponens is in, where is that? Oh, there. Slide 5 and slide 6. Okay. Slide number 5 and slide number 6. Those are the two well-known valid argument form. Okay. So Matthew's
Sir,
problem is modus tollens, isn't it?
yes, I already got the tautology, sir.
Oh, very good, very good. So who did not share the screen yet? Newfield, Jocelyn,
Oh, I got mine.
Billy. Okay, cool, cool. Jocelyn, which slide you dealing with?
I'm slide 24.
24. Okay. So either P or it's not the case that Q. Wow. Okay, I don't know this whether this is P and Q and then not P and not Q. Okay. Or not P or not Q and then N not P, therefore not Q. Oh, it's tautology. Super. Yes, you make it. Excellent, Joseph. Okay. Newfield, Billy.
I got my modus ponens.
Oh, you got your modus ponens.
Yeah,
Modus ponens must be
uh,
tautology. You
tautology.
must be. Okay. This is one of the well-known uh, valid form. Newfield. Which slide are you in? You fail. Which slide is this? 25? No. 26?
26.
26. If P then Q is not Q, then it's not P. Okay. Oh, you get all true. Yes, of course. Because this form is called what? You fail. What is this form called?
What is the true.
No. This form is called modus tollens.
Oh yeah, modus talent.
Okay. This form is called modus tollens. Okay, remember, huh?
Yes, sir.
If P, then Q, not Q, and not P. Okay, so this is modus tollens. Okay, excellent, everyone. Okay, so everyone did it very, very nice. Okay, so let's go to the next slide. Slide number 19, Boolean algebra. Wow, we get a new topic. Okay, it looks like a new topic, but actually the same thing. Okay. Okay, let's go. Oh, I did not share yet. Okay. Here it is. Oh. Can you see this slide already? You can also download from the Google Classroom. Okay. So this is part of Introduction to Logic. You will learn about Boolean algebra, right? What is that Boolean algebra? Okay. So we will use exactly the same thing. Okay. So basic. Okay. Boolean algebra is the study of compound proposition, the same as logic, okay, where the logical expressions are analog to arithmetic expression in ordinary arithmetic. So this is easier than logic. Okay, so the value of each proposition is limited to true or false, right? So you know already the proposition. Okay. So proposition is statement that can only be true or false, cannot be both, right? So every mathematical statement is assumed to be true or false, right? So its proposition can be represented as Boolean variable. Now, true is equal to 1. False is equal to 0. That's it? Yes, that's it. Okay. Easier, right? Rather than you type in Excel, true is 4 letters. Eh? 0 and 1 is just 1. Easier, okay? So the compound statement is the same. You use and or not. Okay? So you will create a compound statement which is called Boolean function. Okay. Okay. If it is true, okay, we will write it as t in here or the 1. Okay. If it is false, it is f or 0. Okay. So, okay, there are many logic operator, okay, but the most important one for you is just 3. Or, and, not. Look at the symbol I put there. Okay. Or I use V, right? But this time we can use plus, we can use bar. Okay, that represent or. Okay, you can use any of them, that's fine. And usually I use a V reverse, right? So at this time you can use multiply. Okay, and then or you can use and like that. Okay, ampersand. That is also and. Not I can use tilde minus apostrophe or top bar. So there are many ways to represent the same thing. Okay, which one you want to use is up to you. Okay, I don't mind about it. Okay, let's use this Boolean algebra, okay, with two binary operation of multiply and plus. You remember plus mean or, multiply mean and. Okay. Now we have a basic law. Okay, this basic law. X, Y, Z is either 0 or 1. Okay, X is either 0 or 1, so it's called Boolean. It's only two values, okay, 0 or 1, true or false. Okay. X is either 0 or 1. Then you can have X plus 0 equal X. X times 1 equal X. So it's called identity law because it will become itself. How about domination law? X plus not X. Okay. Accent there represent not. Okay. X plus not X equal 1. But X multiply X and not X equals 0. 0 means false. So we have associative law, we have commutative law, we have distributive law. Okay. Anyway, if you don't want to memorize, that's fine. You can always open your slide during the exam. Okay, there's no problem with that. Even if you work, you will always do that. Okay, so let's try the basic computation. Okay, so if you want to use Excel, I put it there up. Absolute of 1 plus minus X, that means negation. Yeah. So negation of 0 is 1. Negation of 1 is 0. That means not. Same. Negation means not. Addition. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. But be careful. Here, this is Boolean, right? So 1 plus 1 is 1, not 2. Huh? Okay? 1 plus 1 is 1 in Boolean algebra, not 2. How about subtraction? Be careful also. 0 minus 0 is 0. 1 minus 0 is clearly 1, right? But there is no negative number, right? So 0 minus 1 is 0. This is the special part. That's why I put red in here. This is the one that you need to memorize. Huh? There's no negative. It's negative becomes 0. Okay? There is no number larger than 1. If above 1, become 1. Okay? Below 0, become 0. That's easy. Right? So 1 minus 1, of course, 0. Multiplication is just the same as the ordinary multiplication. So you can also make it binary. Okay? So if X is larger than 1, make it 1. If X is less than 0, make it 0. Otherwise, X. Okay. Then you can use truth table, the same thing. Okay. You already have it. So then using truth table, okay, two Boolean operations are called logical equivalent. What is the meaning? Meaning it will produce the same result if their value in the truth tables are the same. So this is the truth table of n. So I can use true or false. I can use also 0 and 1. Right? Exactly the same. Eh? This is the case. How about or? Or is exactly the same as the truth table in logic. In Boolean, you just replace all true with 1 or false with 0. Okay. How about not? It's the same thing also, right? So, easy. Okay. There's nothing new in here except changing false into 0 and true into 1. Okay. You want to try this? A accent plus B. Can you try this in spreadsheet probably? Before we
Why not in Excel, sir? What is the difference?
what?
How if we try it in Excel?
You
Is
can
there
use
any difference?
Excel. You can use Excel. Spreadsheet is Excel, right? Spreadsheet is actually the Excel is one of the spreadsheet. Is the subset. Okay. In spreadsheet, you can use Google. What is that? In Apple, you
Sheet.
use numbers. In what, Billy?
No, no, no.
So there are many type of spreadsheet. One of them is Excel. Try to use Boolean logic with the 0 and 1, okay, in Excel. Why we use Boolean logic? Sometimes it's easier to use arithmetic, isn't it? Multiply, minus, plus, then or and and. But the meaning is the same. Okay. Anyone can make A accent. What is that? Not A. Yeah? So A accent plus B. What does that mean? Not A or B.
Sir, how do we make the A accent?
A accent. Oh, you can use absolute of a while ago. Where is the function I mentioned? Here. Can you see this? Negation. Absolute of 1 minus x.
So for AXN, we compute manually.
No,
Or
you can use this. This is the formula.
oh, okay, okay. Thank you, sir.
Or another way is to make it into binary, like this. You just multiply and you can just multiply and add and minus just normal number. After that, make it into binary. That's easier. Okay. Once you make it, then you start to see. Oh, which one is easier? Logic or using true and false or using Boolean algebra? It's the same, but it's just the form, right? If I need to choose, I will choose Boolean algebra than logic. Because this is really easy.
So in Boolean algebra, we change the x, right?
You change
X.
the x is, what is the x in here? In this case, the x is a.
No, in the slide before, the basic computation to make it binary.
To make it binary, so x is the argument, right?
Yes, we change the x, right?
Yeah, you change the x into the cell value in Excel.
So when do we put a accent and when do we put d? Where?
Okay, can you share your screen then? I will help you. So how do you make A accent there? Can I see the formula of A accent? No, the previous, the E. Okay, you get the A accent. And then, how about A accent plus P? How do you make that? No need to make that if. So you just plus. Okay, equal. Okay, yes, correct, that one. So D plus, okay, you copy that. That's correct already. So, but still have 2, right? So, okay. Now, that value, now you make it binary. How do you make it binary? Okay, you can make it binary. So, if that value is okay, again, then okay, you miss one more. Is it? Then copy down. You get the result. Okay, you get the result. Okay, 1011, is it? No? Wait, maybe the input is different. Okay. Your input is, oh yeah, the input is different. Okay, that's fine. 10 is the one that's 0, right? Correct. So your result is correct. Okay. Very good. So, how is it, everyone? If you have difficulty, share your screen. I can help you. If you have done it, you also can share your screen so that we can see, oh, you did it like that. Okay. Everyone okay? It seems not. Do you still have problem? No?
Still trying, sir.
Still trying? Okay. Have you learned Boolean algebra before? No? This is first time? Okay. How about logic? Did you learn before in high school? Part of mathematics? No, also.
Only if then.
Only if then. Okay. And or is not there yet.
I don't think it is really look. Just
The
we
detail.
use or and sometimes.
Okay. So let's do Boolean first. Oh,
What?
tell me the simple Boolean like A accent plus B. Can you make it? Okay, so okay, anyone want to share screen? A while ago. Matthew, you want to share your screen? Or
I
Billy?
think I cannot, sir.
Oh, you cannot. Okay. Billy? No. Why? Why you are not confident, Billy? What happened? It's exactly the same as the true and false in logic, okay? The only difference is now becomes 0 and 1. Okay, there's no real difference. Just the symbol is different, like and now become multiplication, right? And or now become plus, not now become minus. So exactly the same. There's no difference. In fact, it is easier than logic. Now, three things, set theory, Boolean logic, and the propositional logic. The three of them are exactly the same. Okay. I will not touch the set theory here much, but you need to remember the three of them are exactly the same. They are equivalent. Jocelyn, you want to share your screen? You make it already?
I haven't got the
Result?
I don't know, the Boolean Algebra one.
Oh, why?
Yeah. I forgot the formula.
You forgot the formula. Which formula you forgot?
The if blah blah blah. I forgot.
Look at it. No need to remember the formula. Look at it, the logic. Boolean, okay, is just the same as true and false. If true, become 1. False, become 0. Now you can multiply, it just become and. You can add, that become or. You can subtract, that's the same as not. Okay. Now, if you want to make it the real value of 0 and 1, then you make it into binary. Okay. So what's the meaning of make it into binary? Because the value is only 2, right? 0 and 1. How about if negative? Then make it 0. How about if larger than 1? Then make it 1. That's it. Okay. No need to
Sir, I
memorize.
don't understand the formula of if.
I will show you again. This one, right? The one that you mentioned, the formula. Is this the one? Is that
Yes,
correct?
sir. Yes.
Oh, this one mean, look at this. If any value x is larger than 1, make it into 1. If any value x is less than 0, negative, make it into 0. Otherwise, x remain x. What It's exactly the same that I just mentioned a while ago, right? If larger than 1, make it into 1. You convert into 1. For example, 2. Then make it 1. Okay? 1 plus 1 is 2, right? Okay? Then 2 become 1. Because there is no other number except 0 and 1. It's binary. Boolean means binary. Okay? So how about negative 1? There is no negative 1. Then becomes 0. Easy. Right? Okay? So, in fact, you can actually compute manually using hand. Okay? Just remember, okay, if it is negative, 0. If it is larger than 1, 1. That's it.
Sir,
Mhm.
I will annotate first. This is x greater than 1. The true value is 1. And x less than 0, the true value is 0. Why? There's x here.
Oh, okay. I will write it down, okay, in another form so that you can make it understand. So I will share here. If then, if I will write it in Python, okay, form. If x, what is that? If x is larger than 1, if x is larger than 1, right? Then what? If x is larger than 1, then x equal 1, right? Else, yeah, that's the meaning is else, right? So you have else in here, correct? So in the else have another if. If x is less than 0, then what? X is equal to 0. Then you have another else, right? Else, what is this? Else x equal x. That's the meaning of that formula. Is this more confusing or?
I don't understand why else x equal to x.
Okay, if you do. Let me write it down in Excel if you want. Okay, I will share my Excel. Okay. Oops. Why? So, okay. So I have so I want to create a binary, right? So let's say I have an x here. Okay, what number I put in here? 3. Okay, so this is my number x. Okay, so I will put it here x underscore. Okay, and then this is the binary of x. Okay, so then I will say if this number, okay, is less than 0, make it 0, or else what? If not 0, what? Not
Mark
0, then
the
another if, right? The else is if that number is larger than 1. If larger than 1, what should we do?
Equals to 1.
Okay. Now, then, else, so if, what's the meaning of else in here? This is not 0. This is not less than 0. This is not larger than 1. Then what?
X equal to X.
Yeah, x equal to x. That means I will copy to that value itself, right? And then I close it, and then I close one more there. Then I can start to make it. Okay, how about if I have minus 2, 0, minus 1, 0, 0, still 0, 1, become 1. If I have 2, become 1. See, can test that. Is it clearer now?
Yes, sir. I understand now. Thank you so much, sir.
Thank you, thank you. Jocelyn, is it clearer now?
Yes. I mistyped the comma. I should use the point and comma, but I use only comma. So the Excel doesn't make.
Error. Okay. So, Matthew, you feel
Yes, sir.
no problem? You got it?
No problem, sir.
So in fact, I can make that. Okay. So here, if you in Excel, you can have a developer tab. Okay, and then you can create a Visual Basic here. So there, I created. Okay. So this is a Boolean addition, Boolean multiplication, Boolean not. So you can make it binary. So this is the formula. Can you see it? Okay. So if s means less than 0, right? So you can binarize. So again, if true become 1, if false become 0, right? You can put logical P. So you convert to Boolean into logical. You can make it so that become Boolean. Okay. Or you can put NOR. The one that is not in Excel yet. So you can also create the function. This is the first function. Or you can put none. It is not there. Right? You can put imply. Okay. And you can put equivalent. So you can create this function so that you can start to create in Excel. So you can check is tautology or not. Okay. And is contradiction or not? So you can also check that. Yeah? Is Boolean or not? You can also check that. Okay, using this, so you can create a function, right? So instead of binary like this, instead of doing like this, I can do equal binary, right? Binarize. Okay, binary of this one. There. So I have a new function. Okay. Excel recognize my function that I created there in the admin. So you can copy that. Okay. So for example, I have a minus 100, 0. Okay. Did I confuse you more or? Okay, let's go to the next topic a little bit, which is called Boolean function. So a Boolean function of degree n, okay, is a Boolean algebra function with n number of variables. So the degree of Boolean function is the same as the number of variables. Is it easy? Okay, so for example, a function of x, y, z. So that means degree 3. A function of x and y. So that means degree 2. Fx only. That's degree 1. Is it clear? So the number of Boolean function of degree n is 2 exponent to 2 exponent to n. Okay, so if you have only one variable, then you have 4 function. If you have 2 Boolean variable, you have 16 function. If you have 3 Boolean variable, you have exponential, yeah? So 256 function. Okay. Okay. So what are the 4 function of one Boolean variable? What are the 4 function of one Boolean variable? Okay. So these are the 4 function of one Boolean variable. Okay. So remember, x is only 1, with this the value is only 0 or 1, right? That means, what is the possibility? Okay, F1 is tautology, F4 is contradiction. What is F2 in here? The negation, right? Look, 0 become 1, 1 becomes 0. Right? And then, what is this F3? F3 is the projection. That means the same exactly as x. Okay, so these are all possible Boolean function with one variable. How about if you have 2 variables? Okay, there are 16 variables of 2. There are 16 functions of 2 Boolean variables. List them all. Okay, here it is. Okay, you have 2 Boolean variables, so let's call them x and y. You see that? X and y. Okay. Then you have F1 until F16. So these are the only, okay, Boolean function with 2 variables. So we call this degree 2. So F16 is contradiction, right? All zeros. Okay. F1 is tautology, all 1. Right? And the others you can check by yourself. Okay, these are the all possible values. So for example, or F2 there is disjunction, mean or, right? How about N? N is conjunction, that is F8. Yeah. How about SOR? SOR is F10, exclusive OR. You see, all possible values are just 16, not more than 16. If you have only 2 variables, it's all combination. Is it clear or not clear, this one? Is it the same as logic? Yes, the logic also have 16, the same. Okay. Any question, any comment, give me feedback. What did you learn? What did you learn? Is this too much?
Yeah, a little bit too much.
A little bit too much.
Yes, sir. It's too much, sir.
Thank you. Okay, I will stop until here. So, you will yeah, eventually you will create something like this. Yeah? Okay, I want you to create what is the the logic function that will give the following output. This is 4 degrees. We have a 4 variables, x1 until x4. Okay, anyway, if it is too much, so please read the slide beforehand. Okay, and then ask more question next meeting about Boolean logic. Okay, Boolean logic is the foundation of computer science, right? The foundation of algorithm, right? So tell me what make it difficult in here? Give me feedback.
The F too much, too many. Suddenly
many F?
F1. Yes, the last one.
Oh, the last one
Suddenly
is the one that too much.
for maybe
This one?
yes. Yes, suddenly 110.
Mhm.
Suddenly there are too many 1 and 0.
Okay, okay. Suddenly they have only 1 0. Okay, okay. Let's do it one by one so that you understand. Your input in this case is only 2, with this x and y here. Can you see it? What is this? 0 and 1 in here. 1 is true, 0 is false, right? Is this clear or not? The first 2 columns first. Okay. So, column 3, this is F1. What is this?
Tautology,
Tautology. Why is it tautology?
because all of them are blue.
Oh, because, huh? Because of
Because
what?
all of them are blue. 1, right?
Oh, all of them are true. Okay, 1. Okay. How about this one? What is this actually? Without looking at the top explanation, can you look at the numbers there? 1, 1, 1, and then 0. When it is 0?
And not
Oh,
when not
when
X
both of them
not
are
Y.
false, right?
Yes.
So, what is this? When it is happening? You remember
When one of
or?
them is blue.
You remember in logic you have or. Can you remember the truth table of or? The
No,
truth
I don't
table.
remember it. I just put it equal or.
Oh. So this is the truth table of or, right? So true and true become true, right? True and false become true. False and true become true. Only when the both of them are false, then it is false. So this is called or. Now I hope you can remember. We already discussed this last time. Remember? Okay, F3, what is this? It is only false when x is 0 and y is 1. What is that? That is the if then. The then if. Okay? The reverse of if then. Okay? So F5 here is exactly if then. Okay. F7, what is this? This is the one that you already know. This is exactly equivalent. Okay? Equal. The equal symbol in mathematics, that is equivalent. Okay? F8 here is N. What is that? Can you see? If true and true, then true. Otherwise, all false. Right? So, F9, you already learned also this one last time. Remember, this is called separate function or none, not n. You look at F8, okay? If you put not to F8, become F9. Can you see that? How about F10? F10 is what is called exclusive OR. This is the not equivalent. Equivalent a while ago was F7. Can you see? If you put not of F7, you will get SOR. F15 is called Pierce function or NOR. What is that? Not OR. Okay, the way you read is actually per column here. Yeah, don't read per row.
We doesn't need to remember it like the table.
Oh,
We don't need to remember it, right?
you don't need to remember. Of course, I don't remember that.
Okay. Don't
Okay,
need to remember it.
yeah, but you need to remember some of them, right? For example, like OR, AND, IF, equivalent, SOR, the one that I just mentioned, right? You need to remember if then, right? Because why you need to remember? Because this is always used anyway, right? So people will tell, why you don't know that and mean both arguments are true. Okay. For example, you do programming later. Okay. When you use and, that means both of them must be true, right? Or if you use or, that means only one of them must be true. Like that. Okay, so this is the foundation. If you don't remember all of this, at least the one that very useful, okay, then you cannot make programming because you don't know, right, whether your program is true or not, right? At least you need to know those function that is always used. Okay? Okay. Tautology you remember, right? Contradiction you remember, right? And, or, if then, equivalent, SOR, at least that one. Okay. Okay, so until here next week you start again. We will have a test up to this point, okay, from last slide up to this point. So only 2 questions, okay, and just 5 minutes or 10 minutes. Thank you.
Thank you.
Thank you,
sir.
sir.
See you.
Thank you, sir.